Welcome to this video. We will show the thermal analysis capabilities of Autodesk Nastran in CAD. During this video, we're going to discuss the benefits of using steady-state thermal heat transfer analysis. Our eventual goal is to find if this brake assembly will fail due to high stress concentrations caused by differential thermal heating. We will focus on the rotor itself, so we can hide the other parts in the assembly. We will look at the temperature distribution of the rotor due to the thermal loading and heat dissipation as a result of convection. Let's begin by specifying linear steady-state heat transfer for the analysis. The material properties can be taken directly from the CAD model. The material models include conductivity that we will use and the thermal expansion coefficient that will be necessary for structural analysis. Next, the part will be meshed. It is expected that this model will be used for stress analysis later on, so a relative fine mesh is desired. For the thermal analysis, we will apply the boundary conditions that simulate the heat flux generated from the friction between the brake pad and rotor, as well as the rate this material releases heat into the surrounding air. All of the faces need to be selected except for the two faces that are coming in contact with the brake pad. We'll put the outside temperature of 293 degrees Kelvin or 70 degrees Fahrenheit. Then the convection coefficient based on the material and ambient airflow. Next, we will apply heat flux, or the amount of power per square millimeter for both sides of the rotor. All that is left is to run the solver. This model takes about 1 minute to solve. Let's take a look at the results for the final temperature distribution. The plot shows the non-uniform temperature distribution that can be used as a load in a subsequent thermal expansion analysis. You can see some of the heat is transferred to the vanes on the inside of the rotor. As you have seen, Autodesk Nastran in CAD and Inventor helps us to come up with a better rotor without leaving the CAD system. We can now confidently move on to innovation on other areas of the brake assembly.